Hey everyone, welcome back to Swift Fundamentals. Today we're covering two important concepts, mutability, immutability, as well as access control. You'll learn how to differentiate between let and var for mutability and how Swift's access control modifiers like public, private, and internal help secure and structure your code. So let's go ahead and dive on it. Let's go ahead and start with mutability and immutability in Swift. Let is used for constants, meaning the values cannot change after it's set, while var is for variables. So if we go ahead and create a structure here, we'll call it user profile. Go ahead and say let username be a string. So this would be considered an immutable property. And if we had a variable, let's call it bio. Also make that a string. This would be considered a mutable property. So here, username is a constant and cannot be changed, while bio is a variable, meaning that we can modify it after creating the user profile instance. All right, let's create a new variable down here. We'll say variable profile. Let's have this equal user profile. And let's go ahead and add the username and bio. So if we try to change the username to be Swift Coder and the bio to be Learning Swift, and we have our profile dot bio equals mastering Swift. We can update that, no problem. But if we try to have our profile dot username, we try to change this later. So let's have this equal to be, I don't know, code master. You notice we get an error here. It says cannot assign property username as it is a let constant. So we're able to change what that bio says after we've initialized it up here. But if we're trying to change the username after it's been initialized, we can no longer do that. All right, cool. Let's talk about mutability in classes versus structs. So in Swift, structs and classes handle mutability a little bit differently. Structs are value types, so changes affect only copies, while classes are reference types, meaning changes affect all references. Let's create a new structure here and we'll call it point. And we can have an x and y value. So we'll say variable x, which is an integer, and variable y, which is also an integer. And down here, let's reference our variables. So variable point a equals point, and let's pass along that x and y information. So we'll say 0 and 0. Then variable point b, and let's have that equals point a. All right, and let's now change point b to equal the x of 10. Point b dot x equals 10. Let's go ahead and now print point a dot x. So essentially what we've done is we said, all right, variable a is 0, 0, and I want variable point b to equals point a, and then I want to change the x value to be 10, and notice that we haven't changed what point a is. So here changing point b does not affect point a because structs pass values by copying. And if we were to do this for a class, just to show you the difference, we have our class here, we'll call it location. We'll do the exact same thing with our x and y. And we'll paste this to save a little bit of time. We'll also create an initializer here. So we need to initialize our x and our y. I'm just going to use the autofill to save some time here. Let's go ahead and now create two constants. We'll say let location a equals location. And we'll say 0 and 0 once again. We'll say let location b equals location a, pretty much the same as we've done above with the structure. And then we'll take the location b dot x. We're gonna have this equal 10, just like we did with the structure. But this time, you notice when we print location a dot x, we're gonna get the output of 10 because this is something that does update. So with classes, changes to location b dot x are also going to affect location a dot x because they share the same reference. All right, let's talk about access control. I'm just going to delete this. We'll do an example including everything we've talked about. But for access control, this is going to help us control which parts of our code can access or modify properties as well as methods. So Swift provides 5 access levels: open, public, internal, file private, and private. So let's go ahead and create an example here. I'm going to make a new class. I'm going to call it bank account. And let's create a private variable here with a balance. And we'll say that it's a double, and it's going to equal, for now, 0.0. I hope my bank account doesn't have that. But what private is essentially saying that it's only accessible within this class. So I'm just going to add a note here. Great. And let's create a public function. We'll call it deposit. And we'll take the amount, and it'll be a double. Let's go ahead and have it be the balance plus equals amount. Great, and we'll create a public function here, get balance, which will then return a double, and we'll return balance. So here balance is private, so it can only be accessed or modified inside the bank account class. The deposit and get balance methods are public, so they're accessible from outside. So let's go ahead and down here, we'll create an account. So say let account equals bank account. Set our account.deposit, and we'll put the amount, maybe $100 here. Then we'll print account.get balance. And that's going to output 100. If we were to then try to access the balance, because again, remember that is accessible only within that class, let's see what happens. So I'll take this account now, and we'll look at the balance. And you notice it doesn't even want us to really type this, right? Like even usually in our autofill feature, it's like, hey, you can do this. It's like, you want to use get balance, right? That's when you can use. But if we were set this to be 500, it'll give us an error saying that it's inaccessible due to being a private protection level. So by restricting access to balance, we prevent accidental or unauthorized changes, ensuring the data remains secure. All right, let's go ahead and talk about FilePrivate, and this allows us to access within the same file, while internal is the default level, making code accessible within the same module, but not outside. So let's go ahead and create a class here. I'm just going to call it FilePrivate example, and we'll create a FilePrivate variable. We'll call it secret, and we'll say file only access. All right, now let's create an extension outside of the class. So let's say extension, then we'll reference our FilePrivate example. We'll have a function in here, and we'll call it reveal secret. And within here, we will print the secret. So this is actually just accessible, the same file only. Cool, so let's combine mutability and access control. So I'm just going to clear our screen here. I'm going to create a new class. I'm going to call it secure note. And from here, we're going to have a private let, say note ID, which would be a string, and a private, you can actually add brackets here for set variable content string. So this is actually going to be immutable externally, as well as being mutable internally. We'll see how that works in a minute here. Go ahead and initialize this as well. And now we'll also create a function. So I'm going to do func update content, new content, which will be a string. In those parameters, and let's have our content now equals new content. All right, let's go ahead and create a note. So I'm going to say let note equals secure note, pass along that ID and content. So the note ID, we'll just maybe set this to be 1, 2, 3, and then we're going to set this to be initial content. So if we do note dot content equals new content, you notice that we're going to get an error that's saying cannot assign property content, setter is inaccessible. That's because externally it's not being able to be changed, but internally it's mutable, being able to be changed. So if we were to just comment this off real quick, on the next line we'll say note dot update content, and then the new content we'll call it updated content. So this is going to be allowed because the method is internal, therefore it's mutable, right? So outside of this class, when we're trying to change that note.content, it won't have it. When we're inside the class via this function, aka internally, it's going to be mutable. It will update. And that's it. Today we learned about mutability and immutability using let and var to control how much value changes. We also explored access control with private and public, ensuring secure modular code. Thank you so much for watching.